Hydrostatics within fluid mechanics delve into the equilibrium and behavior of fluids when they are static or moving at a constant rate, studying their pressure distribution, force transmission and related principles without considering fluid motion or changes into velocity. As you can see, into hydrostatic, we can look at 5 parts, which is definition and basis, which is hydrostatic pressure is the force exerted by a fluid at rest due to gravity, directly related to the weight of the fluid above a specific point. It's a foundational concept in fluid mechanics. Next, fundamental equation described by P rho GH, where P is pressure, rho is fluid density, G is gravity's acceleration, and H is depth. Depot areas within a fluid experience higher pressure due to cumulative weight of the fluid above. Then, diverse applications, crucial across various disciplines, engineering, physics, geology, biology, and more. Its understanding is in comprehending phenomena like buoyancy, fluid transmission, and behavior in containers or bodies of water. Then, engineering significant, which is critical in hydraulic system and civil engineering, determining stability in submerged structures like dams. Lastly, in biological and medical relevance, relates to the human body, specifically blood pressure, and plays a role in understanding how deep sea creatures adapt to extreme ocean depth. In medical fields, knowledge of hydrostatic pressure is crucial for diagnosis and treatment. Understanding hydrostatic pressure is pivotal across a broad spectrum of scientific, engineering, and medical applications, influencing designs, natural process, and practical solutions.
Force of the pressure distribution can be considered to act, causing no-net moment. In simpler terms, it is the point where the applied force can be thought of as concentrate, simplifying the analysis of force and moments on the object. Theory center of pressure. Pressure distribution. When a solid object is immersed in a fluid, liquid, or gas, the fluid exerts pressure on the surface of the object. The pressure distribution across the surface is not uniform. It varies based on factors like shape, angle of attack, and fluid velocity. Next, forces and moment. Each differential element on the surface experiences a force due to the local pressure and contributes to an overall force and moment on the object. Forces are resolved into components parallel and perpendicular to the flow direction. Effect of shape and angle of attack. The shape of the object and the angle at which it interacts with the fluid influence the location of the center of pressure. For example, in an airfoil,
tadi terhadap pembukaan rata. Okey, di hadapan sekarang anda semua adalah sebuah eksperimen yang telah kumpulan kami buat untuk menunjukkan merealisasikan kesan daya hidrostatik terhadap permukaan rata. Okey. Binaan ini adalah macam platform yang untuk kita memegang dia punya tengkuk permukaan ini, dan juga terhadap tengkuk ni terhadap permukaan segi empat sama, terhadap permukaan yang kita nak masukkan lah. So dia dalam eksperimen ini kita orang akan menunjukkan dua keadaan. Yang keadaan pertama pada kedalaman di atas permukaan air dengan dengan permukaan dia adalah segi empat sama. Ni dia. Sudut yang kita kumpulan saya telah tetapkan adalah dalam 35 darjah. 35 darjah secara kasaran dia. Seterusnya, keadaan kedua adalah permukaan, iaitu permukaan bulat yang berada di dalam tangki ini sebanyak kedalaman 6.5 cm dengan sudutnya 35 darjah. Kalau anda perasan, saya ikatkan styrofoam di sini untuk supaya permukaan ini dapat keampungan yang seimbang untuk daya hidrostatik daya hidrostatik bendala ini kenakan sekata pada permukaan bulat ini. Sepatutnya boleh nampak, anda semua boleh nampak permukaan ini terapung. Sebenarnya tujuan binaan projek kami ini adalah untuk merealisasikan kesan daya hidrostatik terhadap permukaan. So kami membina eksperimen ini menggunakan bahan-bahan kita semula yang kami dapat dekat pusat kita semula, dan bekas ini adalah bekas akuarium, dan bendala yang kami gunakan adalah air. Okay. Untuk pengiraan akan dibincangkan pada slide nanti. So sekarang ni saya menunjukkan kepada anda sebenarnya daya hidrostatik ini apabila dikenakan pada permukaan, sepatutnya dia akan terapung dan juga kekalkan dia punya sudut. Dia sebenarnya ada tekanan di sini, tekanan pada hujung permukaan, setiap permukaan untuk setiap sudut yang setiap sudut dan setiap kedalaman yang kita letak. Untuk pengiraan tu kita akan buat kepada case study yang akan dibentangkan di hadapan nanti. Sekarang ni saya nak tunjukkan anda bahawa dalam eksperimen sekarang ini telah kesan daya hidrostatik ini sedang mengenakan dekat permukaan bulat dan juga segi empat sama ni. Tetapi daya tersebut adalah beza pada kedalaman dia. Baik. So daya berbeza dan titik tekanan untuk kedua
Hello, my name is Muhammad Omar K. bin Sabari, and I will continue about the case studies, which is water gate size 5 cm times 5 cm were used to cover the water entrance of a tank, as shown in the figure below. Determine the hydrostatic force act on the water gate and find the center pressure of location when 0 cm. And the condition if H equal to 0 cm. And for the first step, we need to find the Y bar, and Y bar is 5 cm divided by 2 and equal to 2.5 cm is 0.025 meter. And the second step is we need to use the equation, which is I equal to V, which is base, and H height power of 3 and divided by 12. And B is equal to 0.025 and height also equal to 0.025 divided by the power of 3 and divided by 12, and is equal to 3.255 times 10 to the power of -8 m4. And for the third step is sin 20 degree equal to H divided by 0.025, and the H is we got the 8.55 times 10 the power of -3 meter. And the first step is we need to find the area, which is base times height, and base is 0.05 meter and height also 0.05, and we got 2.5 times 10 to the power of -3 meter square. And the fifth step is we need to use the equation, which is F equal to rho GH times A. And the rho is 1000 times by gravity 9.81, and the H is 8.55 times 10 to the power of negative 3 and times 2.5 times 10 to the power of negative 3, and we got the force is 0.21 Newton. And for the last step, we need to find the y prime, which is IC divided by A area y bar, area times y bar plus y bar, and we fill the equation, and we got the y prime is equal to 0.
So this is case study 2. So basically a water gate with a diameter of 8 cm is used to close the water inlet of the tank as shown in the figure below or beside. So determine the hydrostatic force acting on the surface area. So find the location of the central pressure CP when the H null is 6.5 cm. So if we want to solve this study case, first we need to find y bar. So y bar 8 divided by 2 at the total is 6.5 divided by sine 20. So the answer is 23 centimeter or 2 point, sorry 0.23 meter. So the second step is we need to find IC. So you use the formula of the circle, since the water gate is circle shaped. So pi d4 divided by 64. So we insert the diameter of the water gate, which is 0.08 meter. So we conclude. So the answer is 2.011 multiply 10 to the power of negative 6 meter to the power of 4. So the next step is we want to find H bar. So sine 20 equal to H bar divided by 0.23. So the answer is H bar is 0.079 meter. And then we also needs to conclude the area of water gate. So basically use the common formula, which is the pi d square divided by 4. So we insert the diameter of the water gate, and then we find the answer, which is the 5.03 multiply 10 to the power of negative 3, and the unit is meter square. So we need to find the F, so which is F formula is rho GH multiply with area. So rho, we use the water, so 100 density, and multiply with gravity, which is 9.81, and we multiply with 0.079, which is the H bar, and we multiply with area of the water gate. So which is the answer of F is 3.898 Newton. So the final step is we want to find y prime. So basically the formula is IC divided by a y and y bar and add to y bar. So we insert the all the answer of the before this we conclude, and we put the formula, and the final answer of y bar or CP, central pressure, is 0.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Muhammad Firdaus Muhammad, and I'm going to present about limitation on these experiments. So for the first point is surface condition. There's a flaws or surface roughness on an object can affect hydrostatic pressure distribution. For the second point is fluid motion. There's be hydrostatic experiments assume negligible fluid motion, but this may not always hold true. For the third point is scale effects. For the experiment or this simulation on a small scale, so it may yield different result than those on a larger scale. And last but not least, uniform fluid properties assumption. So this experiment or many hydrostatic experiments assume constant fluid density and pressure, which may
Hello, Assalamualaikum. My name is Muhammad Aqiyuddin Nazari bin Maulana. I will continue the present slide. So first, the conclusion study on hydrostatic force. First is essential for understanding fluid mechanics and predicting fluid behavior in various scenarios. Second is provide valuable insight into pressure distribution and force on submerged surface. Second is challenge and consideration. Firstly, theoretical models may face challenge to surface roughness and flaws, leading to local pressure fluctuation. Second is assumption of uniform fluid characteristic may not always represent real-world situation with non-uniform fluid. Next is recommendation. First, meticulously prepare surface to minimize imperfection for accurate hydrostatic force studies. Second is use polished surface to reduce irregularities affecting pressure distribution. And three is ensure precise pressure measurement through regular instrument preparation during experiment. And last, consider surface effect, especially in small case models, accounting for surface tension and capillary effects. That's all.